we all are preparing for our Claude certification. We have a Slack channel where I documented all the courses you need to do, whatever you need to study. I make a week-wise plan for 4 weeks. So if you guys are interested, you can always reach out to me.
Awesome, awesome. Okay, I think this is also a good time to probably just touch on what we covered last class before we proceed. Talked about ICM, interpretable context methodology, and we discussed something we called folder structure as an agent architecture, right? So in this entire session, we talked about folder structure, understanding the need to have your instructions and everything within your project in a way that the AI can actually progress through it or traverse through it and be able to use that as the framework, right? Because we know there's a lot of frameworks out there. We have Crew AI, we have LangChain, and a lot of frameworks. So we discussed on this particular format, on this particular framework that replaces all the code level frameworks that I just mentioned right here. And there's actually a research paper for it that I also talked about. So I talked about how the frameworks already work, the Crew AI, the AutoGen, how they handle multi-step orchestration, memory, tool use, and all of that stuff. And talked about the uncomfortable question where most of these workflows that people are using it for, they need a human in the loop, right? They need a human to confront the output here before it goes through different steps and need another confirmation. So if your workflow is like a straight line with a person at every checkpoint, what is the orchestration framework actually for, right? If, for instance, you're making a content factory, it's going to research the topic, it's going to write the scripts, it's going to create the source material, 10 slides, everything is sequential. So there was a need for you to stop the overkill workflows and actually just change something your foundational layer, right? So we talked about what changing a workflow actually costs today. If you would like to make any change to any of the workflows that I just showed you using the frameworks, how you might need to edit code for everything. You might need to swap out the prompts and remove all the stages. And the hidden tax was the fact that there was hidden opacity. So whenever you see something work, you don't really know what's going on inside, right? Just like you can see here. So you can't open it, you can't read it. Yeah, dots ex, dots dxx, of dll. So all these files, you don't have a way to see what's going on inside. So in order to do that, you have to build a dashboard, you have to build a log table. Like a log table is where every action that is taken in the system is being reported to. So that was the second problem. The first problem was most of these things didn't really need a complicated build. And the second problem was there was hidden opacity. The other problem was insight, right? So the prompts and the context for each stage of your workflow already wants to be in the file. It already was created to be in the file, right? The research brief, your voice, your design system, your skills folders, they're all within the file. So you just need one agent with the ability to read through all these files. So we talked about the concept of ICM. The ICM was a way to kind of layer every file and give the AI enough context to traverse through each file and know what it's supposed to do at each layer of its work. So we talked about a couple of things. I really advise anyone that didn't see it to go get the previous recording. It starts with being able to do one job at a time, right? Break one job, one stage, one job at a time. So a stage that does the research will not also write, right? A stage that writes will not also build. So they took that concept of doing their particular task per stage and then passing the output of that stage to the next job, to the next stage that handles the next job, right? And Playtext being the interface. So we talked about the principles behind it, the layered context loading. We talked about being able to have full visibility because it's in plain text, right? So the problem I talked about, hidden opacity. Here you can see the output because it's in plain text. You can also configure the factory to your taste, right? So it was really good when we talked about it. It started with the Claude.md in the first layer. Whenever there's a load time, whenever you're starting a runtime or a session, that's the first file the agent is going to look at, right? And the Anthropic agent, for other agents, they have their own agents.md and the rest. But Claude comes to the first layer to know where it is. So that's like what I called where am I, right? So it's always loaded when this session is started. When it discovers where it is, it goes into the second layer to know what it should do, right? So the next layer is more like a navigation map, right? And says, okay, in order to do this, you have to go here. And when you go here, this is what you do. So it goes to the second layer. I give it context. And that context tells it what it should do. So that's for each task, right? So for each task, if you want to research, you have to do this. If you want to write, you have to do this. And then reference materials to help in your template, the best practices, and all of that stuff, and working artifacts. So if you understand the concept behind skills, this is going to be so easy for you to understand at the end of the day. We just touched on them. It was a really interesting session. I advise you guys to all tap to it. We picked the business, and I think the business that we chose was an AI agency. So I created a business OS for an AI agency, and I actually have it here. Let me see if I can pull it out here. I can see. Let's see. Okay, this is another brain that borrowed the concepts of ICM, right? As you can see, it's populated right now. So this is the context of inbox file. So when the agent comes, it understands that this inbox is to capture and dump anything, sort it out later, right? Anytime you put anything in the inbox, the agent checks the context and it knows what happens. So what happens is the context, everything that enters the inbox, let's say I'm driving, I have this really nice idea, put it in the inbox. And what happens is that it's later then triage into the ideas folder. So if you look down here, you're going to see ideas, right? So the ideas is where every note that I take is stored. So one note per idea, it breaks down all the ideas. And then if the idea is actually what, it's then going to send it over to the products, right? So I have on another side, another section for products. So yeah, that's basically how it works. As you can see, I have a case for products. So the product context explains the reason why each product is made. I have a marketplace. I know I talked about this recently. So what exactly happens here is the ability to structure my folders in such a way that when I put any LLM, any Claude session here, it understands what to do. It understands where the output of the first layer goes into and what happens in between all of that. We're able to experiment that and build brain for it. So, and if this is new to you, then that means you haven't watched any of our sessions. You should go and see how we created the first second brain using Agile Properties Wiki. And a lot of people have created their own brains by now, and they're doing some great stuff. But yeah, I'm talking about the AI Avengers. I'm trying to load it right now, but I'll probably come back to it at the end of the day. I'm just showcasing how this works. So with the business OS, I've been able to have a system where I can just have lead generation handled for me by the system, getting leads, organizing the leads, doing outreach to the leads. And then when I eventually have a discovery call with someone, what happens is after the call, the transcript is being ingested by my system to generate a proposal to send to them based on the things that they mentioned in the call. So from the transcript, the AI is able to extract what they need, map their ideas, map all the skills they need, and create a deliverable, right? So I've been able to automate the whole process of having an agency, right? So not only that, but you can also do it for content creation. It can research ideas for you, write scripts for you, produce image, video, whatever you need, and publish it for you. If you have a e-com brand, you can do a product research, you can list it, it can run campaigns. It's limitless. And then we have this was the prompt that you use if you want to start up for the first time, and then how to load it into your Obsidian so you can see it kind of like the way we saw it. We talked about everything around and surrounding the folder structure. So I will really advise you guys to go watch the video. It's live. Today we're going to be talking on a new topic, a very interesting topic, which is dynamic workflows, right? So Claude Code just shipped them recently, I think late last month. And most people just scroll right past it. Most people just think, oh, another beautiful update. But there's more to this, right? So in this model, I'm going to cover 6 patterns and the core API behind it, right? So this is the same machinery that Anthropic's own engineers use to run hundreds of agents at once. Like they actually just showed us the blueprint of how they use it to work and just flew right past us, right? So I'm going to show you exactly how powerful this is. You can have up to 1,000 agents, 1,000 sub agents running for you. And a lot of people didn't really get that. What is a dynamic workflow? Let me just give you the picture of what a dynamic workflow actually is. So a normal CRUD session is one model, right? One context window, doing all the thinking. The setup is fine for most of our work. And in fact, we have been using it for all of our work. But it starts to crack when the job becomes big, right? When you need to run things in parallel or you need something to argue against itself because AI is really good at giving you an output. And then when you ask about feedback or find a way to fix it, it tells you everything is good. That's until you now take it to a skill called LLM Council, or you take it to another model, and then you come to see that there could be some adjustments, there's some weaknesses in it, right? But you ask the AI that generated the output, it's going to have some bias towards its output. It's going to say that, oh no, this is the best output so far, unless you have to prompt it and tell it, hey, fix this, hey, do that. So sometimes you actually need more agents, right? So a dynamic workflow actually flips that arrangement. It allows Claude to write its own architecture, right? Its own orchestration, a small file, and then it spawns it everywhere. Like what happens is Claude will write an orchestration harness. It's going to write like I'll put it like it's going to create a factory of some sort, and then it's going to also create a small script, JavaScript, right? A tool script, and it's going to use it to spawn a lot of sub agents, right? And each of them will get their own context. Each of them gets their own model, and each of them gets their own goal. So basically, dynamic workflows is Claude giving itself the ability to create or spawn multiple agents. And now, not saying that Claude didn't have the ability before, right? But I'm going to explain to you exactly what happens in this sense. So it has a plain JavaScript, right? And for those of you that know JavaScript, it's programming language. It's going to handle the data that's moving between the sub agents. So that way the sub agents can actually communicate, pass things among themselves. And I got this from the creator of one that just started in here. He said dynamic workflows, in my personal opinion, is the state of the art today for reliably using agents to complete medium to large projects, right? Because doing medium to large project before will require you doing extensive job, burning through hours, in order to get things done. But with this workflow right now, you can have hundreds of agents working, each of them with their own goal, each of them with their own model and their own context window, communicating with each other in order to like see it through to the end. And if you remember when we talked about the previous ICM, this is just like a build on top of ICM. ICM encourage using a single agent to do the work. And then I showed the limitations, right? If you're doing something that requires the LLMs to interact with each other, if you need something that requires a multi-agent communication and passive work between each other, that ICM will not be the best fit. This right here is the best fit. So ICM gives you the foundation, right, for all of this to work in accordance, right? So here's what that buys you over a single session, right? If you get isolated context, right? So every sub agent works in its own clean window with one job and nothing's going to leak between each of those tasks, right? And then you can have per agent model, right? So you can have Opus for the hard reasoning. You can have Haiku for cheap explorations and having sonnets right in the middle, right? In the best of both worlds. So the workflow actually assigns the right one to each job. So you have that amount of control of not only spinning hundreds of sub agents, but being able to even decide what model the sub agents use, right? And you also have something called per agent isolation level. It's a work tree, right? If you're familiar with Git or remote. So what actually happens is that the workflow decides what agent to touch, right? It decides what agent to trigger. It decides what agent to use for a certain task. So that's what gives this much more power. And we're going to see it when we actually start using it over the single way of maybe just running a few sub agents in the same Claude session. So the way it worked before was Claude, if Claude was supposed to spin up a sub agent, I'm going to show you that in an example. Just say, hey, Claude, I want to do this and do that. I want to create a website. I want to write some copy for this website. I want you to also do a research. Can you spin up 3 agents to do that? It's going to spin up the agents and assign them the task. And when they are done, they're going to turn those tasks within its own context window, right? But in this essence, you can't do that for hundreds of agents. So that way, each of them have their own window. They have their own model and they have their own isolation level. That way, no agent is trampling on the other agent's foot, right? So you may already run static workflows because they have the normal static workflows. Those ones that are done with the / p, I use it to connect to my Telegram. I use it to, use this agent remotely. So those are written once to survive every edge case. So they have to play it safe, in some sense like that. But a dynamic workflow is written for one task, and after that task is done, it's thrown away after, right? So it's more like the same question, but there are two ways to answer it. So it's either you use a static harness, which is generic and conservative. It can search, it can summarize, but it doesn't know how your billing code exists. So it can't read it. It can't price it against your real volumes. It can't do other certain tasks, but you can actually have a dynamic harness that shape itself to your context. It reads your code, it reads your context file, your Claude.md. It checks out each feature against the new provider docs, right? It prices at your actual value. It actually runs everything as though you, because it has its own context window, right? So that's the difference between the static and the harness that's built for your specific task, right? Because the static harness is just playing it safe. It's just, you just created a room that anyone can fit in. But the harness that is built for your task is actually built for your goal in mind. It's actually built to achieve your deliverable, right? So that is one of the things I wanted to highlight. So we're going to talk about the three modes of failure. So give me a second while I on the other deck. I think that will also make this really understandable. 1 second. Can you see my screen?
Yes.
Can you see?
Yes.
Okay, great. So, like I was saying, I talked about the mental model, right? So each sub-agent gets a clean window and has one job to do. Like I said, it's a state of art state for reliably using agents. I've already gone past all of this. So why one context window fails and why the other actually stays on, right? So I wanted to make it more visually appealing so that way you can also get the whole idea, right? So the two ways a long session breaks is agentic laziness. I know it might sound, what is agentic laziness? So simply put, agentic laziness is when the clock stops partway through a multitask and calls it done, right? It makes 20 fixes out of 50 items in, let's say, a security review and reports the rest as handled. I don't know if that's ever happened to you. You give it a task, it goes ahead, and then it says it's done. And when you check it, it's like, oh yeah, you've done this part, but what about this part? Right? So that's because the session was too long and it breaks during those sessions. The second part is self-preferential bias, right? The power I mentioned, and I told you guys that sometimes you might ask an AI agent to grade itself, and you find out that it's grading the way it grades its own work, it favors it, right? If a reviewer with a stake in the results can't grade fairly, right? Someone that is own ultimate goal is to find the bugs, find the flaws in the system. When you give that output, they're definitely going to find it. So it's when you ask Claude to give his own take about something, it's like telling the author to mark their own exams, right? So that is another thing that you have to think about. So the last one is the goal drift, and this is very important. So sometimes you can have the agents, you can give it a goal, and across many tons of the original objective, it is going to start fading, especially after a lot of compaction, right? If you know the use case of compacting your conversations when your context window is getting filled up. So I'll break it down a little bit. So in previous sessions, I mentioned what context rot is. And yeah, imagine you're using a 200K context window, a model with 200K, or let's say you're using Opus, the latest one with 1 million context window. Once you're way past half of the context window, and by half, I mean you've burned out 500K for a 1 million, 100K for a 200K context window, you start to see that the output of the agent is going to degrade. The output of the agent is going to drop. And why is this? It's because every single time you're chatting with the model or you're giving it an instruction, it's taking whatever you're saying and it's appending it to the conversation, the conversation window, right? With all the tool calls, all the MCP calls, all the read and writes, all the time that it has to read through your code in order to understand the context of what you want it to do. All of this gets filled and fed right back into the context window, right? So when you reach a point of context rot, it doesn't go so well. The output is always starts to degrade. So the best use case or the best solution so far is that when you've gone past the 50% limit, what you do is you compact. And compact is basically giving Claude the ability to summarize everything you've discussed with it from the beginning up until 50% where you're currently at. And then it starts a new session, it starts a new conversation issue with a blank slate, and then drops the first message as the summary. So that's what the compact is. So when you compact something, just pressing the whole conversation into one single chat and starting a new conversation with that chat as the first message. So that way you're able to keep working with Claude, keep going with the project that you're working on, and Claude is going to understand exactly what it is you're trying to achieve and just keep going from there. But the thing is, over time, the more you compact, the more you summarize your project and start a new conversation with that summary, the more it starts shifting away from the goal, right? The more it stops to see the full picture, right? So that's basically what I mean. So every summary loses a little bit of goal. For instance, you could have had a role in a conversation where you're like, don't do this. And that quietly vanishes when you've compacted more than 20, 30 times, right? So those are the three failures. And I took my time to really break down these failures because it will get to a point that you start to notice this as you're working with a single session, with a single workflow, with a single approach that we're currently using. And the experts at Claude, they have already gone past that phase, right? I mean, if you have the Claude at the power of fingertips, if you have Claude with all the max tokens, you're definitely going to use it and you're going to start seeing things this, right? So that is one of the ways long session breaks. So what do we do? Each failure mode has a structural fix, right? So they started releasing models and releasing features to prevent against this. So for the laziness, you have the fix of loop until it's done plus the goal feature, right? I don't know if any of you guys use the goal feature. It's actually really amazing. You just give it the slash goal in Claude Code and you write the goal. And the agent is going to continue looping and verifying, going back and forth till it completes that. And by so doing that, you end up with a model that doesn't hit and bail, right? It doesn't stop halfway and say it's done because it has to loop until it is done. It has to check until it is done. It has to ensure that the goal has been achieved before it's done. So that's the fix for that one. For the self-preference, for the ability for the model to always favor its own output, the the fix for this is having an adversarial verification, right? You have another model that has zero context, zero knowledge of where this came from. And its entire goal is to review and find vulnerabilities in it, find places for correction. That is the way to fix that. Because if you keep asking the same agent that generated or the same LLM context that generated the output to review it, it's also always going to say, oh, this is good because of this. These are the strengths. This is why this is the best output. But if you take that and you give that best output to another model or another context that has zero knowledge of where this came from, and its entire goal is to just find flaws in this output, you're going to find those flaws, right? And then for the goal drift, the structural fix is to fan out into isolated context, right? So basically, it means that when what you notice is when you have long tasks that wander from the original constraint, just fan out and get an isolated context, which is what we are going to touch on in this session, right? So these are the three functions that carry the whole thing. There are three functions that carry everything, right? I'm going to show you the core of the three functions that carry everything. Like I said, today is going to be more of walking you through a new feature. So we're not really going to build anything serious today. Just trying to just bring you up to speed on what is actually going on in 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 the world of AI today. So these are the three functions. We have the agent function, we have the parallel function, and we have the pipeline function, right? So I'm going to touch on the agent function so you get an idea of what the agent function is. So the agent function is spawns the sub agent, right? So this is the function that actually brings the agent to life, right? With its own context. So you give it a prompt, it picks the model, it defines the shape of its output, and it runs alone, right? So this is the atom, as you can see. Everything else is more coordination. This is the atom. This is what makes the agent come to life. So with this atom, you can spin up one sub agent, you can give it its own context, you can give it its own window, and it runs alone. It just takes it off and runs alone, right? So for the barrier agent, right? For the barrier agent, for the parallel agent, this is how you find them out, right? And then you wait for everything, right? So it's a barrier, right? Nothing moves on until every agent has returned, right? So you allow this agent to work in parallel, right? So every agent is working, you find them out, and you wait for everything to come back to you. So you use it when the next step leads all the results together. So it's the parallel is just going to check, do I need everything before I continue? If you do, then it's going to spin up the parallel agent. The parallel agent is going to ensure that everything is done before taking you to the next step. And then we have the pipeline. So the pipeline just streams each item. It allows each item to flow through every stage on its own, right? It's just a cheaper and faster way overall to move things from one stage to the other, right? So the result actually has to arrive before the whole batch is done, right? So that's basically how it works. So for the pipeline, each item just has to flow from each stage on its own because of the pipeline. So the one question that picks between them is, do I need everything before I continue? If it's yes, then it's going to be parallel. If it's no, then it's going to be the pipeline. So the pipeline is more of a sequential way to do things, whereas the parallel is running everything at once. So both at once from the boundary, right? This is actually the code, right? So it has one agent and two adversarial reviewers per file, right? So I'm just going to zoom in a little bit. So I'm not going to walk you through the code, but I'm just trying to show you that this is the parallel, right? So it's running the parallel here, and it's also running the agents here. As you can see, you have the review agent, apply the review. As you can see, you have the adversarially review this port, gave it the model as outputs. So this is giving the model as outputs. This one is supposed to apply. So this is just basically how it works. So all you just have to do is tell Claude what you want to do, and it's going to find out the rest. And this is exactly what he did, right? So create a workflow that reviews every file in the source code, right? For security issues, one agent per file, right? And then merge the findings into one prioritized report. Use SK tokens. So by giving out this prompt, if Claude Code is going to look at, okay, how many files do you have here? Because he asks for one agent per file, and then it's going to spin up one agent per file. So that agent knows that its entire focus is going to be on that file. It doesn't need to read all through the code and float up the context window. It can read just that file and find all the issues in that file. So this gives us the ability to send the agent out and it comes back with results, right? So that's exactly how a dynamic workflow works. So let me talk about the 6 patterns real quick, right? This is the real workflow that stitches 2 to 4 things together. I'm going to talk about the 6 patterns now. The first one is to classify and act. So these are more the building blocks, right? So a real workflow usually stitches together 2 to 4 of them, right? It's not just going to be one workflow. Workflow is going to stitch multiple workflows together. So once you know the patterns, you can read or shape almost any workflow that Claude writes. So the first one is that Claude is going to classify and act, which is basically is going to route the work before doing it. So a classifier decides the type of task first that it needs to do. Then the workflow sends it to different agents or different models, right? So you spend the expensive models where only the real work is going to earn it, right? So you're going to use it when the tasks are mixed or on the right treatment, depending on the input. So it's going to decide the task, then it's going to route it to the right agent. Then they fan out and synthesize, right? So you can have one agent per item in parallel or a synthesizer that merges all of them together. So what happens with that? So the first part, after classifying the task you want to do and sending it into the workflow, the next part is going to break those tasks into little items and then run one agent per item in parallel, right? Then there's going to be a synthesizer. The synthesizer is basically just waiting for all the individual item agents to come back with all their results. So it's going to wait for all of their results and it's going to merge them together. So that way, each agent sees its own slice. Each agent only works with its own slice. So that's basically what happens with the fan out and synthesize. And then we have the adversarial verification, right? Which is the fix I told you for the self-preference, right? So each of them is going to have a separate verifier that sees only the rubric and the artifacts, never the author. It never knows where this is coming from. So that way, anything that is reviewed is fact-checked and graded, right? So as you can see, for this one, you can have any list of independent items, right? 50 files, 200 leads. Imagine having the ability to spawn individual agent to research each lead and then come back to you. So that's basically how this works. So the adversarial review, just like I mentioned, for each of those worker, they're going to have a separate verifier. And that verifier is only going to see the outputs and it's going to have a way to score it, a rubric way to score it. It's never going to see the original work or who made it, right? So it's useful when a wrong answer is costly or anything that is reviewed needs to be reviewed, or if there's any output that needs to be reviewed, that needs to be fact checked, right? So that's the third pattern. So if you go over to the other pattern of the workflow, the other pattern is to generate and filter, right? So basically to generate and filter, it's going to generate 10 to let's say 30 options by a rubric is going to drop duplicates and it's going to return only the few that survive. So that way it stops Claude from locking onto its first idea, right? So because sometimes when you're brainstorming or when you're trying to think of a name for something or you're trying to decide on what to use, sometimes people always end up going with the first output or the first suggestion from AI. But the best part comes the best output or the most unique output comes from reiteration, going back and forth with Claude. This is exactly how I want it. This is what I need to be done. So that's how this workflow works. So it's going to come up with options and it's going to replicate and return only the ones that are unique, right? Return only the ones that are worth the investment. And then the other pattern is the tournament. So basically what it means is that it's going to put itself in some sort of a position where you can spawn, let's say 10 agents on the same task, but with different approaches. And then you compare the results in a pairwise bracket until one wins, right? So you get this result, which one is better. you drop the loser, you get the next one. So that way, it's a better way of scoring, right? It's a better way of ranking, especially when you want to rank 1,000 items, or you want to judge designs, or you want to pick the best out of many tries. So that is how it's just going to be. It's going to be a sort of a tournament. When you knocked out of a tournament, you're out, and the better team stays. So that's basically how this pattern works. And the last one is loop until done, right? So done is a condition. Done could be when the website is done, right? When the website is created, when it's functioning, right? So it will keep spawning agents until a stop condition holds, just like the slash goal, right? It's given the goal, it's going to keep going until the work is done. And this is basically for a work of an unknown size, right? Maybe you don't know how big this work is going to be. You just have an idea of type of work, but you don't know the amount of time or effort that goes into that particular one. Excuse me. So what happens is the workflows is going to keep spawning agents until a stop condition holds. Maybe there's no new bugs, or all the tests are green, or the theory has been confirmed. So you're going to use this. It uses this when the done is a condition. It's not a count, right? It uses this in terms, maybe you're having the tests, or you're hunting for bugs, or you're doing like open-ended research, right? So imagine you're building out a website, or you're building out an app, or a software. This is actually where it's going to shine, right? The goal is keep searching and keep testing. I keep going through reviewing each section of this code until you find no bugs to report. So you can have code going through loops. It finds one bug, it reports the bug, it shows you the bug, it recommends a fix for the bug. It goes again to search. It finds another bug. It goes through the ways to fix the bug. It reports the bug. It can go then until there's no bug to report anymore, right? So that is when to use the loop. So in hindsight, you get the whole concept behind the reasoning of these workflows. And a workflow can be a couple of these things together, right? From 2 to 4 of them. You can have a workflow that will classify the tasks and then spread them across multi-agents. You can also have other agents review the output of the multi-agent that you spawn. You can also have maybe each agent generates maybe a couple of options, and then just validate it down, filter it to get the best one. You can have them compare each of their results among each other and until they find the best one. And you can also have them run in a loop, right? Until you get the winner. So you match the pattern to the failure, right? So if you have a drift from your goal, if something is drifting from your goal, that means you need to fan out the agents. That means you need to ensure that you preserve as much context by sending them out on different context window to do the task that you're giving them. If you find out that there's a self-preference, you then use the adversarial approach. If you think that you have an open-end task, you don't know how long it's going to take, then you use the loop feature. If you think that it's hard to score, it's hard to decide which one is the best, then you use the tournament. So the moment you can name the mode or the failure, you can be able to match it with the drifts, right? If it's a drift, you can match it with the fan out. If you're noticing the LLM is favoring its output, its bias, you can use the adversarial verification. If you notice that you're in an open-ended task, you don't know how long it's going to take, you can use the loop until done, right? So that's basically how it works. So the creator of Born was able to use this pattern I just showed you to prove that this actually works, right? He was able to rewrite 750,000 lines of code, right? In Rust. He was able to put them from Zig to Rust in weeks, right? In like a few days. Something that would have taken a natural team of over 30, 40 people, nothing less than 6 months, right? So this was the clearest real world run of the dynamic workflow so far that I've seen on the internet. And it's the sharpest signal of what's now possible for any large structured job. With workflows, you can actually do a work that will have needed a team of 50 people running for 3 months. You can have this was a clear evidence of this thing showing, because he had 750K lines of code generated in within 11 days from the first commit to the merge. And it passed 99.8% of the test when it started, right? Excuse me. So it had 6,755 commits. 6,755 commits. And for those of you that probably not used to these terms, a commit is basically, it's a change, an update. Let's put it that way. So let's say you write some code, you make an update. You write another code, you make an update. You write another code, made an update. So the workflow carried out 6,755 updates in the span of 11 days. In the span of 11 days. Now, depending on how savvy a software engineer is and how many hours it devotes to writing code, if they were supposed to change this type of code, they might not have gotten up to 500 or even 1,000 commits in 2 months, because they have to review, they have to go back, they have to test. But the ability to have a dynamic workflow and spawn multiple agents and have each of those agents compare their results, each of those agents score the result, each of those agents working on it for the task, which is to convert it from Zig to Rust, and not stop until the work is done. That is what dynamic workflow is. This is the true flow of its power. So just one workflow worked out the right Rust lifetime, right? One workflow converted a code base and built it into what you're seeing right now. So how did they have dimension? Hundreds of agents wrote each one file, right? So hundreds of agents wrote one file, and they all had another agent review the file, or maybe two or three agents. I don't know how I did that. And no agent touched another file. No agent touched another's file. All of them worked in parallel, right? So you have hundreds of agents that are writing a file, writing it in a programming language. You have two people at reviewing it. And if there's any error, it goes back to fix it. And it had a fixed loop. So the loop was until you have completed it, until you have reached the condition of a full build, don't stop. So because of that, your build, it had a build and test suite, and it had to go back and reiterate until everything ran clean. So this is basically how it works. And it was an overnight optimization. It's something that you just turn it on overnight, and it will find things like you didn't even know existed, right? So the dynamic workflows and the adversarial code review were part of what made this possible, according to what he said, right? That was what made it possible. So I said, these are the 4 workflows that run it. Lifetime mapping. So he built a 600 line reference that every agent later used. So this is the lifetime mapping. Then he did parallel ports, right? So hundreds of agents with each one writing particular file. And okay, as you can see, he had 2 reviewers per the file, right? So one agent is writing, 2 agents is reviewing. One agent will review for security, one other agent will review for completeness. If it passes the review stage, it gets shipped to the next, that's completed. If it doesn't, it has to go back and figure it out. Then the fixed loop, right? It drove the build, it drove the test until both ran clean and stopped on the condition, not on the count. So it stopped on the condition that both of this build and test, they ran clean, right? And I said overnight optimization. We found wasteful copies, right? And opened a PR each for the human review. So this is what the agent did. The agent not only ran this, but also found copies that were not needed, and he opened it for the human to review. So he said dynamic workflows that we're talking about and the adversarial code review were part of what made it possible to rewrite Born in Rust. So that's basically what the CEO said. So I know we've been talking about how to use it for devs and for how developers are using it, because it's a very clear indication that this is possible. But these patterns don't really care about the domain, right? You could use it on any part of your industry or any part of your work life. So I'm going to walk you through the differences. So this is the same pattern, right? A developer might want to use it for code-based migration. They might want to change their code base. Maybe for you, you might want to clean your CRM. You might need to, you might want to deduplicate, right? Maybe you have the same people twice in your CRM. You might want to validate thousands of records. You want to validate if these emails are still working, if these people are still reachable, if they are still your clients. You want to find dead leads in your pipeline. This is a workflow that can do that for you. Now, you can research with claim verification with as a developer, but here you can carry out competitor intel and each claim is sourced. Let's say you have 30 competitors. You can spin up workflows that will go and research those 30 competitors and bring back their output. Whereas before, the agent is going to research one and give you the output for one, research the second one, give you the output. This one does it and it only gives you the output when all of them are done, right? Another one for developers is what we call security audits or the bug hunts, right? So it's looking for issues in the code, looking for vulnerabilities in the code. As a business owner, you can have the agent review your contracts, right? So you can have a contract with different clauses and you have each agent review each particular clause, right? And in each of these particular clauses that's reviewing is going to have a risk hunter that's going to tell you, okay, what is the risk of this clause, right? So, okay, this clause is good, but here's the risk. You can also use it for inbound triage. You use it on a loop, or yeah, you can use it for lead triage, right? So you can classify by ICP, you can classify by hot or cold, and if this works for you 247. So what am I saying? I'm saying that no matter what industry you're in, no matter what business you're in, the fact that if you can understand on a high level what this dynamic workflows is and the power it has, you find out that you can do anything, right? At a higher rate, at a higher volume, right? So like I said, you can cleanse your CRM. For those of you that are also looking into creating CRMs or using CRM, you can research competitors in parallel. You can check your contract. You can pull signals from support, from usage, from billing. If you're looking, if you're trying to investigate something that happened, you don't need to look at one place and go check the other. You can have the agent check every possible loophole and get everything done in one run, right? So this is the right way to internalize this, right? You name the failure mode that you're suffering from, then you pick the pattern that will structurally prevent that from happening. So that's basically how it works. So getting one running. So we have two triggers and three levels. So if you want to get it running, all you just have to do is say workflow in your message to Claude, and then Claude writes an orchestration plan and follows it in that order. So when you ask for a workflow to do a certain thing, it's going to write a plan for it and is then going to execute it. Right? I have a list of some leads that I've gathered. Workflow will be the best way to say, okay, go ahead, run a check-in on these leads and score them based on their ICP, or find out what industry they're in, right? Research the company, find out what industry they're in. That's what workflows can do easily. This is something that you might have needed to maybe spin up an automation for if you use NNN in the past. This is basically what NNN workflows used to do, but now you're giving each agent the ability to run in its own context window. Each agent that is checking each lead has its own context window, has its own tool use, has its own model, and it gets to you get to do so many things. It's like you have the power of 1,000 now, power of a 1 to 1,000, right? The other way to use it is using ultra code, right? You set the effort to X high, and Claude decides on its own whether the task that you're giving it needs a workflow, right? And then you can also recover them. Let's say your terminal got closed or something. You just need to resume the session, and it's going to pick it up from where it started. So you can use it through the workflow by just using workflow in your prompt, or through the ultra code or way. So these three levels make sure that it is unattended safe, right? With the /goal, right? Which is a hard finish line. Don't stop until this thing is true, right? /loop. which, like I said, the slash loop is more like run this whole workflow on a recurring schedule, right? Continue run this workflow on this schedule. And then you have to put a token budget. Very important. You have to put an explicit cap on what one run can spend, right? So you have to ensure that one agent has a budget, a token budget. Don't spend up to, don't return more than 3K tokens, just like you saw. Don't use up to more than 5K tokens, right? Because the task that each agent is taking is very little, right? Depending on the task actually. But when it breaks it down, for instance, the one I talked about, lead research, all you just need to do is take the leads information, take their domain, check them online, check what they do. So I don't need to give it a lot of budget because its task has been reduced to a very sizable quantity. So runtime limits. So right now, 16 agents at once, right? 1,000 total per run. So the script can't touch the file system, only the agents can. So this is something to bear in mind while you're doing it. So that is how it works, right? So I can just use ultra code adversarial review and tell it, can you create an agent that does this or create a workflow that does it? Different ways you can get creative with this. So at the end of the day, you just have to know that the workflow script itself can't touch your file system. It can't touch your shell. It's only an agent that can do that, right? At the end of the day. So would what would you use to determine if something is good for a workflow or is good for a regular session? How are you able to determine that, right? When do you need to determine that? That's the next part that we're going into. So how do you determine if something is a good news for one or don't? Do you have 50 files that need the same change? If you do, then yes. If the accuracy is very critical, you need to verify the thing that you're doing, then yes, you will need to use workflows. If you want to figure out the best out of a list of options, then you need to use workflows. If you want to do a bug hunt, if you're hunting for bugs in your system and you don't know how many bugs it would uncover, then you're going to need the loop, right? So because it's an unknown count, you're going to need a workflow, right? You also need continuous lead triage. You're going to need a workflow. So at the end of the day, you just have to think about it. For each failure, right? For instance, for the 50 files, if you actually want to run a single Claude session of 50 files, you're going to burn a lot of context and you're going to have to compact your conversation a lot of times, right? For those of you that use Claude very well, what I'm talking about, before the agent is done going through 5 to 6 files, you're almost at 50% context rot, and you still have 40 files to go. But using a workflow, every agent is going to spread out to those 50 files, and they might not even use up to 5 to 10% of their context window. So every output is consistent. The thing with the regular session is the first 10 files that need change might really go well. But the moment you start loading the context window and going beyond the 50% threshold, you start to find out that the first set got more, they were more intention behind it. It was more accurate, but the other ones following after are a bit mid. So how do you overcome that problem? By doing the fan out and synthesize method, right? The fan out and synthesize method that I mentioned earlier, where you create multiple agents, you fan them out to the 50 files, and when they are done, the synthesizer waits for all 50 outputs and then combines everything together. That's how you get over the 50 files part. So for the reports where you need accuracy, right? You need to be sure about it. You don't want the AI to just come up with something and at the end of the day, it's not that factual. It's not well thought through. And when you ask the agent to give you the review, it's going to say, this is great. This is the best output here. There's no flaw in here. For you to get more accuracy, especially if what the output you're taking, it's going to be published somewhere, it's going to be sent out somewhere, then you need the adversarial verification, right? Why? Because self-preference is a real risk. Also, for the options, let's say you have 20 options, you're going to use the generate and filter. you're also going to use the tournament. For the bug hunts, you're going to use the loop until done, right? You're going to use the loop until done. So anyways, that is basically what you need. Is this a task that can be, is a quick 5-minute task? You don't need a workflow for that. Is it one simple code question you're trying to build? You don't need a workflow for that. Anything a single session can finish fast, you will need a workflow for that. The only time you would need a workflow is if whatever you're doing, would actually span and needs a volume. It's voluminous, right? When a workflow reads untrusted content, tickets, script pages, forms, the agent that reads it gets no power to act. You need another agent that has never seen it before to do the acting, right? So a 30-minute read-only reader removes an entire class of injection risk. So what am I saying? I'm trying to say that at the end of the day, if you're looking to work with agents, you should be able to decide. You as a human, you as a builder, should be able to decide, because I always mention you're the director of your own movie. You're going to be the one to decide, okay, do I need multiple agents for this? Or can one agent do this? How quick can one agent get this done? Versus having multiple agents working at the same time, right? Because there's only so much an agent can focus on at the moment, right? Unless you now want to create some agents, right, to look into the other things. So that's basically how this works, right? So dynamic workflow is a game changer, guys. The more you start playing with it, the more you get to know how good this thing is. So there's one rule that's never optional, right? Always quarantine untrusted inputs. Things, tickets, forms, script pages, any content that you didn't write, right, could carry a lot of prompt injections, right? And an agent can read untrusted content, but that agent that reads it should have no power to act, right? It's only supposed to read it, digest it. A separate agent that never saw the raw text should be the one to do the acting, right? So when you do that, when you have a 30-line read-only reader, right? We have like 30-line, that means it's the code, right? If you have an agent that just does the reading, you're going to remove yourself from entire class of risk, which is called prompt injection, right? So prompt injection is just the ability for a hacker or a malicious actor to squeeze or maneuver some prompts and get the agent to carry out the task that he did not know it's that it's not supposed to do, right? So you can say, oh, I want you to give me all the information about this user, and you squeeze it within a normal request. The agent is going to read every other thing and then take that prompt and then generate all the information about the user and send it over to you. Right? Because the agent that is reading it is the same agent that is acting it, right? But at the end of the day, if you have a agent that only does the reading and doesn't have the ability to act, you remove yourself from that entire class of risk. I mean, that vulnerability, you will never have that vulnerability to begin with, right? So where do tokens go to die? This is actually a very interesting topic, right? Because there are a lot of mistakes that waste tokens, right? So I'm going to walk you through all of them. So these are one of the anti-patterns, right? Using a workflow when a regular session could have actually been able to do it for you, right? So that's one of the mistakes that some people might want to use. Most ordinary tasks don't need a panel of 5 reviewers. You just need to start simple and then escalate it when you hit a failure mode, right? You might not really need to start with the with multiple workflows, with dynamic workflows. You can actually start simple. And I said, when you hit that failure mode, which could be you're running out of context or the agent is drifting from its goal, right? Or you have multiple options, you don't really know which one to pick, or you're running something that you don't know, it's unknown, right? You don't know how long it's going to take. The outcome is unknown and it's not a count. You're not trying to scrape or generate 100 outputs. You're trying to generate based on a condition, right? So that is when you can use a workflow. So that's why I started this session by explaining to us the different type of failures, right? And then setting out a workflow with no token budget. That is where you can see your token budget is going to go off the roofs, right? So you have to ensure that you always run a cap. You have to set one every time that you're using it, right? And then one agent doing the work and doing the review, right? That is not going to work. At the end of the day, you're going to have the self-preference show up every single time to favor the worker, right? They need to be in separate context windows, right? They need to be in separate context windows. The next one is treating the parallel and the pipeline as the same, right? So the barrier matters. You have to put a barrier between all of them, right? So the parallel has to wait for all of them to be done. Whereas the pipeline streams, right? The parallel waits, gives all of them the work and waits. The pipeline takes the first one, feeds it into the next one, and the next one feeds it to the next one in a sequential manner. So if you use the wrong one, you're going to break your step. So you have to be able to know when to use the parallel, when you need the agents working in parallel versus when you need the agents working in the pipeline, right? So also skipping the goal and loop patterns, right? If you skip the goal on the loop patterns, then you're not going to get the end goal, right? Without it, the run can stop at the first soft finish, right? Because this agent can get the job done, but it hasn't gotten the goal done, right? So you need a hard stop, or you need to declare. You have to declare it when it's done early, right? If you want to ensure that this works, you have to put a goal, right? You have to put a hard stop. You're going to stop when this goal has been achieved. If you don't do that, it's going to declare any time that it's done with the task as it being done with the entire project, which is not supposed to be that. So yeah, and then letting untrusted content reach the actor, that's also a very bad sign. You should never let untrusted content to be the same agent running the actions. So you have to always try to make sure that there it stays separate, right? The reader stays separate from the actor, right? And also sorting through absolute scores instead of a tournament, right? You having to manually verify or having to manually sort through absolute scores is actually not the best way to go. Imagine scoring 1,000 items on a 1 to 10 scale, right? That is not going to work. You're not going to score 1,000 items on a scale of 1 to 10 and think you might pick the 10, right? Because there's lots of them are going to have fairly similar scores. So the pairing tournament, the pairwise tournament is going to be more accurate, right? So that is also some mistakes that you should try not to make, right? And never saying never saying the workflows that work, right? So never if you don't save the workflows that work, right, into a skill, you have to start reprompting the same shape every time. And that's going to be a waste of tokens, right? So in order for you to get this to work, just the way skills were invented in the .claude folder that you have skills, now we have workflows. So you have to save those workflows. Whenever you have a workflow that you created to do something, you have to save those workflows, bundle it into a skill, right? Rather than repumping it. So that's the mistake that some people do that makes them end up wasting tokens and not getting their job done. So basically, that is one of the things that you should really bear in mind. So you have some things to remember. So these are 5 things that matter most. And it's something that I want you all to work out of this with. So a workflow is a harness, right? A harness is everything surrounding the AI, right? The harness is the tool use, the web search, right? The ability to read documents, right? The harness is the house, is you're given the agent is the brain, right? And the harness gives the brain hands to interact with your system to run the workflow. So the workflow is a harness that Claude writes for itself and is built for your specific task, right? So that is one thing that you have to understand when you come across the word workflow, right? Claude writes this thing. And there are 3 failure modes that tell you when to use one. The first failure mode is when you see the laziness of the LLM, right? The AI laziness, not and by laziness is being not able to complete a task, and then it's coming to tell you, oh, the task is completed, right? When it's not complete, or when it's biased about its output, this output isn't right. This output is suboptimal, but the AI is telling you to your face that this is good. All right. And when you see that the goal is drifting from what it was originally, intended to do, that is when you know that you're supposed to use a workflow, right? So, for instance, if the workflow is lazy, you're going to put a slash goal. So, or you're going to put the loop until it's done. That way, it is not lazy. It has to go and check the goal and then compare the goal with the output that it created and ask itself, is this done? No, you just created a page of a website. You're not done with the whole website. Okay, go back. It goes, it creates the other pages. It says, is it done? Okay, you've created the other pages of the website, but you have not published this website. So that way, the AI is not going to, be caught being lazy. If the AI is biased, then you have an adversarial reviewer, right? So that way, someone is going to tell you, you know what, this your output is shit. This is why it is shit because of this and this and this. And then the agent goes back, works on it, sends it back to the reviewer. They say it's still shit. Change the header, change this, and it goes back and forth. So this is when you now tell yourself that, okay, I need a workflow. When the AI is being too supportive and praising its own output so much, right? And then I said the code drifts, you definitely know where to use it. So parallel is a barrier and pipeline is streams, right? So when you see parallel is a barrier, you have to wait, right? So you pick whether you need all results first, right? Before moving on to the next, or you don't really need all the results first. That's when you pick a pipeline. So again, they separate the author from the reviewer, right? Always, so that there's no bias in the output, and save the workflow that works as a skill, because that way they compound, right? That way you're able to get it running as it should. So I mean, I could go on and say other things. You saw how someone was able to rewrite 750 lines code in 11 days, right? Not with one AI, but with 100 of coordinated AIs. You saw how the slash goal command plus the loop until done allows you to run a condition as long as it's established a while loop. If you're familiar with while loop, run a while into a don't stop until it's finished type of thing. So when you use the goal is going to ensure that it doesn't stop until the goal is finished. Always remember to quarantine untrusted inputs, right? By allowing a reader to only read and not be able to carry out any action, right? So I also want you to know that this is only for developers. I use the developers use case because that's the one that shows it in order of magnitude how crazy this thing and it is, right? So just to give you an example, so if someone could rewrite 750 lines in less than 2 weeks, something that would have taken a team of 50 over 3 months, and they won't still even have accomplished it, that should tell you how far you can go if you use it correctly. So yeah, so this is how you're going to turn it on. You need to have either the pro plan. If you have the pro plan, you can activate it from the dynamic workflows. In the section, you have to tweak it on. If you're using the max plan or the team plan, you don't need to turn it on. It's on by default. You just say workflow in your prompt and you're going to see it turn on. Or if you're using the enterprise version, then your admin has to it has to set it up for you. So if I was to spin, let's see, let me just open up a new session and share my screen. So let me know where you can see my screen. So the whole point of this is stop writing 50 prompts, write one workflow, name the failure, pick the pattern, and set the budget. That is basically how you get this thing done. So I'm just going to show you, I'll show you a little example so you get idea of what it looks like before. Okay. So let me just run Claude, skip missions. Good. The moment I write workflow, it changes color, right? Because I'm on the max plan, as you can see here. So see, as I type the workflow, it changes color. So that's how you know that the workflow has been integrated. So tell me about workflows, and then it is going to just give me a brief understanding. Then I can then ask it, okay, let's create a workflow for something. So you're asking me to explain workflows, not run work. So let me do that rather than launch anything, which is running a workflow. Say running a workflow will spin up agents for no reason. So it knew what I was trying to do. So it's just a JavaScript that I'll write and run. It's going to write it and run it, and it's going to orchestrate multiple AI sub agents, right? Deterministically. So instead of me doing one big task in one long stream of reasoning, I write code that fans work out across many agents, collects their result, and synthesizes an answer. So this script controls the structure, what runs in parallel, I explain what verifies what loops and everything. So it explains why we should use one. So I can say, do you want to see it in action? Give me a real task, review a code, research a workflow, and it's going to run it. So I'm thinking, what can I do right now that I would need to do a workflow? Let's see. Next for give me suggestions. Because my Claude knows what I need. Just to show you guys how simple this is, and it's not hard at all. So so you can see it's giving me different things. Map this code base as a workflow. So it's asking me what direction would you like to go? Let's see. Let me look at the files in directory first, then give you 5 workflow suggestions. Okay. Scope my project. So I'm going to show you how it works. So let me look what's here. So it's reading the file to get context. Can you guys see my screen? Do I need to increase the? Can you see my screen, right?
Yes.
Okay. Awesome. So as you can see, review and hardening. It can review my code base for bugs. It can do a security audit. It can research something as a workflow. Can give it something to research, and it goes ahead to research it. So in here, yes. So we can actually pick on from where we stopped with the two fours. So basically, I have some mock pipelines, right? So workflow, lead proposal. If you watch a previous session, we only touch on the onboarding and the main part. We didn't touch on all of this stuff. So it's asking me, okay, do you want me to build this out for you? This is the best fit. I can say, okay, yeah, go ahead and build out these 5 stuff. Now, if you remember in the last session, I had to, we're only able to run, Manoj, if you remember, we're only able to run the production layer, right? And Manoj, you remind
Yes.
me, and I think just the onboarding, right? But
Right.
now with this workflow, I can actually get everything done in one go, right? So that's basically how it's going to work. So now it's reading the context, so it can spin up the agents. So it's still reading, as you can see. It's reading all the workflows. Let me see if I can open it up. Let me open it. I always use this to open. Okay. All right. So yeah. So I said this is basically what I've been working on, right? For the business OS. This is what we started working on previously. And I even ran it with I had a call the other day, and I decided to check it out. So I took a phantom recording, if you guys can remember how it works with the other with this particular one, right? If you remember, I had the agent create an actual transcript in order to run through the pipelines and try the ICM structure from the kickoff call so that it could run all the other workflows. As you can see, we have the lead proposal workflow, and we have the onboarding workflow. We have the road OS production, which is the part that we worked on the last time. These other ones were just empty. So the workflow now is going to work on this one. But that's not why I'm here. I'm here to show you this part. I actually took a real transcript of a call and I ran it here. And as you can see, this is the call. This is the output of the call. So we talked about the lead I was talking to saying it was not on the closing side and all of that stuff. And then there was some action items. I was supposed to send them an email, and they were supposed to email me their website and their social media handles and all of that stuff. So why am I showing you this? All I did was send the transcripts to this OS, created this kind of summary. It's for a real estate agency in Dubai. And what else did it do? It created, so this is the client. It created the transcript. It created, where is it? It created an email for me to send out to them. Yeah, I think it's around here. Okay, so this is the intake. This is the output of the intake. Yes, here it is. So this is what they need, right? So it gave me a summary of the prospects. It gave me their own problem from the transcript, right? And explicitly what they didn't want. And it also showed their buying signal, right? It showed all of this information about this client, right? So the person on the call, what they do, they run the account, they run the marketing. This is their deal flow, and their company name wasn't stated because they said they were going to send a website. So from this, I've been able to create a follow-up email, right? Just like you remember when we touched on, I think when we talked on, I think was it Keystone? Yes. In Keystone, they talked about needing an accounting OS, an account manager OS, an accounting employee that will send post-call emails right after the call. So this system already sent me an email that says I could forward to the lead. So why am I showing you this? This is just a use case that I built last week because we do this every Friday. And already it's taking shape. I have actually run a real lead through this system, and it's already giving me amazing outputs, guys. It's already giving me amazing output. So I'm just trying to push you guys to always keep testing this, keep trying this out, and yeah, we can see how it works. So it's asking to audit the 5 workflows. Okay, sure. So as you can see, these are the things that we ran them through. So there's nothing to build. Actually, the 5 are done. So there's no need to do that. We can just audit it. So the agent has seen that, okay, I've already written stuff here. Like I showed you, I already have a lot of content here. So there is no mock data. There's no stuff. So it's looking for what next it can do. I just want to show you the power of these workflows in action. Okay. I'm just going to let AI do its thing. So it's altering the audit workflow now. Okay. So now we're going to the audit workflow. Since I have something inside, let's just audit it. Right? So one agent per workflow audits against the role OS autonomy, anatomy, and everything. So this, as you can see, the workflow has been spun up. Let me just zoom in a little bit so you can see. So you see, anywhere you see the workflow, you know that the workflow has actually started. So the workflow is running in the background. It has 5 audit agents, path finding verification, and it's going to have a ranked report. It will notify me when it's done. So what it's doing, each of the 5 workflows, I want to, the ones I showed you, they get an agent that reads the anatomy of it. It's going to read the flagship as a reference. Then it's going to audit its assigned pipeline across the structures. It's going to check for cross references, the naming conventions, and the substance. So every finding then gets independently rechecked, right? And everything before it counts. So I get the confirmed gap. I get everything plus, not plus sounding false positive. It's going to be very neutral. It's going to be very real with me. So you say you can watch it live with /workflows. So let's see /workflows. This is amazing. So as you can see, 5 agents, each of them with the 1 million context window of Opus 4.8. I look at the tokens that they've been given, look at the tools they have. So they're on the audit phase. After the audit phase, they go to the verify phase. Though that hasn't started yet. So they're still currently on the audit phase, right? So you see, audits 5 and 6 have been completed. It's waiting for the remaining agents to be done. And this is something that if we were doing this the way we did it in the last session, I'll click OK, and it's only going to run the first audits. It's going to give me the output for the first audits. I'm going to make some changes. It will ask me, do you want me to go to audit number 2? And then I'll say yes. And then it's going to run again for another, say, let's say 3, 4, 5 minutes. Okay, I'm done with audit 2. Would you like me to go to audit 3? But now, in less than 3 minutes, I've been able to do the work that was taking me, let's say 10 to 15 minutes. So you see, it's done, auditing it. Now it's verifying it. As you can see, it's already done verifying 2 of them. So this is how powerful the workflows actually is. So if you're someone that's building stuff with me, you're someone that likes to research a lot of things, you have 1,000 ideas. Now you can have the research, run those 1,000 ideas, run those 1,000 simulations, and come back in a short span of time, right? So just showing you in real time how this works. As you can see, this was done in 59 seconds, 40 seconds, all working independently, right? They are all working in their own zones, right? So there we go. There we go. There we go. This is amazing, guys. Very, very great. So I think we're in the last phase. The last one is you verifying. Once it's done, yep. So that one was done in minutes and a few seconds. So the dynamic workflow audits, this thing has been completed. Now it's ranking everything. So this is it did the fan out method, sent all of those agents, and now it's doing the synthesizing, which is combining all of their output so that it can present it to me. So 14 agents to confirm and look at the findings. So this is what it found. The severity of this is high. So it's talking about the problem with this pricing, right? It's talking about, oh, the pricing for each of this is 4,005, but in the packages it's 2,005, which is 80% over. You see? So all of this stuff, it was able to find out in less than 5 minutes, right? So this is medium, same file. So they found some same files in there, why this matters, and look at the fix. So this is the fix that you have to do. You want me to apply the fix now and stuff like that. So this can also be my code base. This can also be my lead list, but this is workflows in action. So this is a really powerful tool. And I said, well, why did I need to use workflows? Or why did the agent suggest you use workflows? Because it needed to check all of these things. And one agent will not be able to do that, right? One agent will not be able to audit and verify. He needed two agents to do that, right? And he needed to do this until it was complete. That's why it came off with this. So yeah, guys, I'm just gonna clear this now. And there you go. I hope you were able to take something from it. Guys, if you're not using Obsidian, this would be a good sign for you to start using Obsidian. It is the way, is the truth, and it's data at the end of the day. So I hope you were able to gain some insights from this. If you have any question, this might be a very good time to bring it to my attention, or you can talk about it. So guys, any question? Awesome, awesome. Okay, so no question. Like, I guess I either did a very good job at explaining it. It's a really simple concept at the end of the day. You just need to kind of understand it. And that's why I said today I wasn't going to go into any build, because I wanted you guys to start opening your minds to the possibilities of what you can do and how this can help you scale your current work and the way you're already working to another whole level. So yeah, guys, I really enjoyed this session. I also was happy to share some of this information over to you. The presentation and the recording will be live as always. Before we drop off, there's something I wanted to mention. We are about to start a Claude certification program. So if you're interested, it's going to really be good that you have this along your skill bag. So we have a way to follow up. We have groups to chat about our progress. And it's something that I can get done in the shortest amount of time possible, so that you can have something to show and back your cloud knowledge and back all the things that we do here, right? So if that's something you're interested in, if you want the certification, I'm going to send you the link. You can start watching the courses and we can all be doing it together. So it's a learning program that we can all work together. But yeah, thanks for your time. I really appreciate. Manoj, you want to add anything before we on go?
This was really powerful, bro. Thank you again. And I realized those frameworks per day where they have the hierarchy that this is CEO, this is social media manager, agent, this. And I think
Yeah.
that things are bullshit, because the
Yeah.
core is deploying parallel agents. So there's no hierarchy in between them. It is just a shared context, right? So if that's why I deleted those frameworks where
Yeah.
going crazy about AI company, and that's bullshit. That just
Yeah.
losing your tokens.
Yeah.
No checkpoints. There's no reviewers. You showed us. There's no
Yeah.
validation. There's no streams. And this is how AI works. It's not human company where you need to control your subordinates.
Yeah. Yeah.
Yeah, it is really good to see that you can deploy hundreds of agents without you designing the prompts. Like AI is deciding, okay, I need 5 sub agents, I need 50 sub agents, and it is sharing the context, and everyone is running in parallel. In 1 minute,
Yeah.
10 sub agents
Thanks.
run. It's not one agent run for 1 minute, then another one, another run
Yeah.
for
Yeah.
2 minutes, and you're just wasting your time and money. So this is really good. I'm gonna try it.
Yeah, I agree. I'm gonna use it to speed run a lot of audits and work that Claude has already done because I believe that way it's gonna really shine at the end of the day.
Mm. Perfect, bro. So
Awesome, guys.
yeah,
So maybe the next session we're going to build something really good. We're going to build something real big, combine all the knowledge that we have been able to amass during all these sessions. And yeah, I'm open to any topic or anything that you guys have in mind to build, so we can explore it together.
perfect.
So yeah, awesome, awesome, awesome. Really appreciate you guys tuning in. See you same time next week.
Yeah, right. Thank you so much.
Awesome, awesome, awesome.